Hey everyone, welcome to Ladboy Coding. Today, let's solve problem 33. Search in a rotated sorted array. So, give an array. It is shifted towards either left or right. We don't know how many points is shifted. And also, given a target, we need to find out the index. If the target is not in the array, we should return -1. And there's no duplicates in the array. The question asks us to write an big O log of n algorithm. And we can see that this problem is very popular among interviews. So since the running time complexity has to be O of log n, the first thing that jump into mind is binary search. But how to binary search in a rotated sorted array? We know that if the array is sorted in the ascending order or in some order, we can use two pointer to do a binary search, right? But it is rotated. So our first step is to find where it is rotated. Otherwise, find the smallest element. So, for example, if the array is like this, we need to find the position of 0. And the position of 0 is 4. Because 0, 1, 2, 3, 4. And then, since we know how it is rotated, we can assume that the target is either in this part or in this part. And we can check, for example, if the target is 1, we know 1 is larger than 0 and smaller than 2. So we can do a binary search on this side. Otherwise, if it's a 6, it is not bigger than a 0, and it is bigger than a 0, but it's also bigger than 2. So we know we have to do a binary search on this side. Then we just binary search on the right side where we have target. Yeah. So let's jump into the coding. The most important step is still to find where it is rotated. So how do we do this? Indeed, we need to get the middle point. Then so what does this mean? It means we need to, for example, give this array, we get the middle point, a 7, and we see that 7 is larger than 2. So we increment the counter of left. 7 should not be bigger than 2, right? Because in the ascending sorted array, 3 has to be smaller than 5. So yeah. First, let's print the position of left. It should print 4. 4 is the hold on. Oh, never mind. It is here. So the middle element should not be larger than the right element. So here. Yeah. So we can see that now we find where the smallest element is. Then what do we do? So this is the first step. And then second step, find each side. So now, given this array, we know that the left index is a 0, the smallest element is 4, and the right index is 6. Then let's try so if target is larger than nums, start. So this means the target is within the range of index between 4 and 6. Then we know the left index is here and the right index is here. Then we know we need to binary search on this side. Otherwise, we binary search on this side. Yeah. So to understand this algorithm, let's print left and right. So test case, if we search 1, the left and a right index should be 4 and 6. Yeah, 4 and 6. If the value is 6, then the left and right index should be a 0 and 4. Yeah, it's correct. And then we can do standard binary search because we know the left and right boundary. So yeah. If we find it, we just return the index. So if the middle target is, if the middle number is larger than target, then that means the target we need to find is on the first half of the array. So we change the number of the right index. Otherwise, we change the number of left index. And then we just return -1. So, and let's try 1. It's correct. So let's submit our code. Okay, so this is the edge case. If there's no list, we just return -1. And then we can submit our code. Yep.
Okay, thank you very much for watching. If my solution helped you, please feel free to leave a comment and subscribe to my YouTube channel. Thank you very much and have a good day.